In 1948, a new nation was born on one of the driest landscapes on Earth. More than half of its territory was desert. Its largest freshwater source was hundreds of kilometers away from where its growing cities and farms needed it most. For many experts, the problem seemed impossible. How could a country surrounded by deserts build a future when water itself was its biggest enemy? But Israel made a decision that changed everything. Instead of accepting its geography, it challenged it. Over decades, engineers built a massive network of pipelines, reservoirs, desalination plants, and recycling systems that transformed a water-scarce nation into one of the world's most advanced water management systems. This is the story of how Israel built a water network through the desert and changed the future of an entire nation. When the State of Israel was declared in 1948, its founders inherited a hard truth. Roughly 60% of the land was the Negev Desert, a vast, dry expanse in the south, while almost all the country's rainfall fell in the north, around the Sea of Galilee, hundreds of kilometers away from where farmland and future cities needed to grow. The idea of moving that water south wasn't new. As early as 1902, the concept of channeling water from northern rivers to irrigate the desert had already been imagined by visionary thinkers dreaming of a Jewish homeland. But dreaming about a solution and engineering one were very different problems. Israel in the 1950s was a young, poor country absorbing waves of immigrants, with almost no capital and limited technical infrastructure. Building a nationwide water system meant convincing a fragile economy to gamble an enormous share of its budget on pipes, tunnels, and pumping stations running the length of the country. Planning began in earnest in the early 1950s, led by Tahal, Israel's National Water Planning Authority, working alongside American engineering expertise. The concept they settled on was almost brutally simple to describe and almost impossibly hard to build. Capture water at its most abundant source in the north and physically carry it, uphill in places, across mountains, valleys, and desert, to the driest regions in the south. It would come to be called the National Water Carrier, and it would define the next era of the country's development. Construction on the National Water Carrier began in the 1950s and continued for years, a race against the young country's growing population and its shrinking margin for error. The scale of what needed to be built was staggering for a nation this size. Engineers designed a system stretching about 130 kilometers, from the Sea of Galilee in the north down through the center of the country toward the edges of the Negev. The system combined every method available to move water across difficult terrain. Enormous underground pipelines built from steel and concrete, kilometers of tunnels blasted and carved directly through solid rock, open canals that carried water across flatter stretches, and giant pumping stations designed to lift millions of liters of water uphill, defying gravity at several points along the route. Some sections were deliberately built underground not just for efficiency, but for protection, given the carrier's importance to national survival. At the very start of the system, near the Sea of Galilee, water was drawn in through a submerged pipeline and lifted by a major pumping station, then sent cascading south through the network of tunnels, canals, and pipes engineers had spent years designing. Reservoirs were placed strategically along the route, holding and treating water, smoothing out the flow so the system could handle both drought years and wet years without collapsing. By June of 1964, after roughly a decade of construction, the National Water Carrier was completed at a cost that, adjusted for today, would be worth billions of dollars, an almost unthinkable investment for a country still finding its economic footing. When it switched on, water that had only ever reached the northern Galilee could now flow, reliably, into the parched towns of the Negev Desert. The impact was immediate and transformative. Towns that had barely existed as dry desert outposts suddenly had a permanent, reliable water supply. Beersheba, once a small desert town, grew into a genuine urban center. Arad, founded in 1962 as one of the country's first fully planned desert cities, could now function because of water arriving through the carrier. Smaller desert communities across the Negev, previously unimaginable as places to build permanent life, began to grow. But moving water to the desert was only half the battle. The other half was making sure that water wasn't wasted once it arrived. And that problem produced one of the most quietly revolutionary inventions in the history of agriculture. In the 1930s, an Israeli engineer named Simcha Blast noticed something strange. A large, healthy tree growing in a yard that appeared to have no water source at all. Digging beneath the surface, he found a small leaking pipe joint, slowly dripping water directly onto the tree's roots for years. That single leaking pipe planted the idea for what would become drip irrigation, delivering small, precise amounts of water directly to a plant's roots instead of flooding an entire field and losing most of it to evaporation and runoff. Blast spent decades refining the concept, and by the mid-1960s, working with his son, he had built a practical, scalable version of the system. In 1965, they partnered with a kibbutz in the Negev desert to manufacture it commercially, founding a company called Netafim. Drip irrigation allowed plants to absorb the overwhelming majority of the water applied to them, compared to much lower efficiency from traditional flooding methods. Combined with the newly arriving water from the national carrier, it meant Israeli farmers could grow far more food using far less water than almost anywhere else on Earth. Today, the majority of Israeli crops are grown using drip irrigation, and the technology invented from one leaking pipe is now used by farmers across the globe, including right here in American states like California and Texas. While the world focused on Israel's pipelines and desalination headlines, the country was quietly building something arguably more radical, a system that treats sewage not as waste, but as a resource too valuable to throw away. Here's a number that should stop any American water manager cold. The United States currently recycles roughly 1% of its wastewater. Israel recycles close to 90% of it. Nearly 9 out of every 10 gallons that go down an Israeli drain, shower, or toilet are eventually captured, treated through multiple stages of filtration, and pumped right back out. Not for drinking, but for agriculture, irrigating well over half of all farmland in the Negev desert alone. The centerpiece of this system is a facility called Shafdan, near Tel Aviv, one of the largest wastewater reclamation plants on Earth and a site the United Nations has cited as a global model. Shafdan treats the wastewater of an entire metropolitan region, running it through biological treatment and then through a remarkable natural filtration process, pumping the water into sandy soil, where the ground itself acts as a giant, slow-motion purification system before the water is drawn back out, clean enough for large-scale farming. Israel now operates dozens of large-scale treatment plants nationwide, representing hundreds of millions of dollars in investment, adding hundreds of millions of cubic meters of usable water back into the system every single year. Water that, in most countries, including the United States, simply gets treated to a minimum safety standard and then dumped straight into rivers and oceans, gone for good. Spain, the world's second-best country at this, only recycles about 20% of its wastewater. Israel isn't just ahead of the pack, it's lapping it. For decades, the national water carrier, drip irrigation, and wastewater recycling together allowed Israel to function. But by the final years of the 20th century, the underlying math had turned against the country. Population was growing fast. Consecutive years of drought were shrinking the Sea of Galilee and the country's underground aquifers. By the mid-2010s, the gap between how much water Israel needed and how much nature was providing had grown into the billions of cubic meters. The old model, capturing, redistributing, and recycling whatever freshwater existed, had a hard ceiling. There simply wasn't enough natural freshwater in the country to support a modern, growing economy. Israel needed a source of water that didn't depend on rainfall at all. Surrounded on one side by the Mediterranean Sea, the answer had been sitting there the entire time. The challenge was turning salt water into something a farmer or a family could actually use, cheaply enough and at a scale large enough to matter. Starting in 1999, Israel committed to a long-term, large-scale seawater desalination program, using a method called reverse osmosis, forcing seawater through ultra-fine membranes at high pressure to strip out the salt and leave clean, drinkable water behind. It was not a new idea globally, but almost nowhere had it been deployed at the scale Israel was about to attempt. Between 2005 and 2015, Israel built and activated 5 major desalination plants along its Mediterranean coastline. The largest of them, the Sorek plant, opened in 2013 and became, at the time, one of the biggest seawater reverse osmosis facilities on the planet, capable of producing around 150 million cubic meters of fresh drinking water every single year, from a facility covering a footprint smaller than most people would expect for a plant supplying an entire region. The transformation these plants produced was almost hard to believe. Within roughly a decade and a half, desalinated seawater went from a marginal experiment to the backbone of the country's domestic water supply, at points covering the large majority of Israel's municipal and household water needs. The pressure on the Sea of Galilee eased. Aquifers that had been dropping for decades were given room to recover. And crucially, these new desalination plants were connected directly into the original national water carrier infrastructure built more than 50 years earlier. Old pipes and tunnels from the 1960s, now carrying water manufactured from the sea, moving in directions the system's original engineers had never even designed it to flow. What Israel built at home didn't stay at home. The engineers, scientists, and companies who solved the country's water crisis turned that expertise into one of Israel's most successful export industries. Israeli water technology companies now operate in dozens of countries, building desalination plants, wastewater treatment systems, and drip irrigation networks from India to Africa to right here in the United States. California, wrestling with its own drought cycles, has looked directly to Israeli engineering for guidance on both desalination and water recycling. Texas cotton farmers use subsurface drip irrigation systems descended directly from Simca Blass's original invention. American officials and water agencies regularly travel to Israel to study a system built by a country a fraction of the size of California, with none of America's natural water advantages, that nonetheless figured this out first. What Israel built was never really just about pipes, pumps, and membranes. It was about a mindset, a decades-long refusal to accept that geography was destiny. When this nation looked at its empty landscapes, its shrinking water sources, and its growing population, it faced a choice that every water-stressed country eventually faces. Accept the limits of nature, or engineer a way beyond them. Israel chose the second path. Generation after generation, engineers transformed an impossible challenge into one of the most advanced water systems on Earth. They carried water uphill across mountains in the 1960s, connecting distant regions through a national network of pipelines. They helped farmers grow crops in some of the harshest environments on the planet, using precision irrigation that delivered water exactly where plants needed it, drop by drop. They built systems that captured, cleaned, and reused wastewater, proving that water does not have to disappear after a single use. And decades later, they turned toward the ocean itself, developing massive desalination facilities that transformed seawater into a reliable source of fresh water. But the real achievement was not a single machine, a single pipeline, or a single technology. It was the ability to combine science, engineering, and long-term planning into one national strategy. Today, as many regions around the world face record droughts, falling reservoirs, and growing competition for freshwater, the questions Israel faced decades ago are becoming global questions. How do you support growing cities when rivers are shrinking? How do you feed millions when rainfall becomes unpredictable? And how do you survive when the environment around you is changing faster than ever before? Israel's story does not mean every country can copy the exact same system. Every nation has different climates, resources, and challenges. But the lesson is universal. Water scarcity is not only a problem of nature. It is a problem of innovation, planning, and the willingness to build something different. Because sometimes, the greatest resource a nation has is not the water already beneath its soil. It is the determination to create solutions when that water is no longer enough. And in a world where fresh water may become one of the most valuable resources on Earth, the nations that learn how to manage every drop may be the nations that shape the future.